Let's explore a fundamental quantity of electricity, voltage. Voltage, also known as electric potential difference, is the measure of force that drives electric current between 2 points. It is called potential difference because of the separation that exists between these points of opposite charges which possess a certain potential energy. Imagine water flowing through a hose. The water pressure pushes the water through the hose from a point to another. Another analogy is the pressure difference created by a pump that causes water to flow through a pipe in a closed water system. This pressure created explains voltage as the driving force in electric circuits. Voltage is measured in volts and is represented by the symbol V. Voltage is a fundamental property of electricity and is used to power devices and machines. It is also an essential concept in understanding electric circuits and electronics. Up next, voltage labels. Voltage labels are letters or abbreviations used to identify and represent different voltage sources or supply rails in circuit or electronic device. Voltage labels are used to distinguish between different voltage sources, example VCC, VBus, VDD, etc. The labels V plus stands for positive supply voltage, V minus negative supply voltage, V in input voltage, and V out output voltage. In this circuit, you can spot out some of the labels mentioned. V in equals 5 volts and V out equals 3.3 volts. This symbol here is used to represent an ideal voltage. An ideal voltage is a perfect, constant and stable voltage source. This voltage applies in theory and it maintains a constant voltage level and is also not affected by load changes. That is to say, the changes in load resistance will not change the voltage supplied. An ideal voltage source has zero internal resistance, but a practical voltage source has some internal resistance. The V out of an ideal voltage source is always constant regardless of the input voltage and is 100% efficient. Heat is not generated on the input or the output and 100% free from noise. Here are the common voltage labels used in the industry. VCC, voltage common collector, is a positive voltage supply pin in electronic circuits, particularly in integrated circuits. It provides the necessary voltage for the current to function. It is usually represented with the letters VCC, and it's essential to connect VCC to a suitable power supply and GND to complete the circuit. VBUS, voltage bus, is a shared voltage rail that supplies power to multiple components. It provides a nominal 5 volt supply to power connected peripherals in USB devices. Looking at the picture, VBus here simplifies the circuit design. VDD, voltage drain, is the internal working voltage of a microelectronic device or digital circuit. It is used as a positive supply voltage for circuits using field effect transistor FET, generally called MOSFETs. From the circuit diagram here, 12 volts is the VCC and 5 volts is the VDD. VDD is the fixed digital operating voltage that supplies power into the chip, enabling it to execute instructions and communicate with other components. It is called VDD because when a device requires current to function normally, it draws from the VDD pin. The difference between VCC and VDD lies in their application and voltage levels. Well, VDD is the working voltage of the chip. VCC is the power supply voltage of the circuit. VDD refers to the positive supply voltage for circuits using field effect transistors and is usually less than or equal to VCC. And VCC refers to the positive supply voltage for circuits using bipolar junction transistors. Note here that VDD connects to the drain pin in MOSFET and VCC connects to the collector pin in transistors. The common thing here is that VCC and VDD are both the supply voltages. Inverters use MOSFETs, which you can see here, for switching to enable DC to AC conversion. In solar inverters, the MOSFETs are turned on by VDD range of 5 volts to 15 volts. Some may use a higher VDD range such as 20 volts to 30 volts depending on the specific application and required output voltage. Do not get confused. VDD and VD are related but distinct concepts in electronics. VD, voltage drain, is the voltage at the drain terminal of a MOSFET, which can change depending on the circuit's operation. In some circuits, voltage drain VD appears, telling you that the voltage at that point is not fixed. In cases where VDD and VCC are connected together in a circuit, as shown here, they become electrically equivalent, meaning circuit doesn't need separate nodes. All the voltage levels of VCC and VDD are the same, and the advantage is that the number of power supply pins or traces are reduced, simplifying the circuit design. This shade connection is often seen in digital circuits with a single power supply. Here the supply voltage VCC from the battery VBAT is directly connected to the VDD, which powers the entire circuit. VDD to VCC shared connection is also often seen in analog circuits with a single voltage source. Here the VDD pin out and the V plus equivalent to VCC are directly connected together. And finally, the shade connection is also often seen in mixed signal circuits where the analog and the digital sections share a common power supply. Here the analog circuit connects to the digital circuit with the help of the V-bus connector. The V-bus connector also helps reduce the number of power supply lines, and which enables easy addition or removal of components. VSS stands for negative supply voltage in field effect transistors FETs, and often shares the same potential as ground GND. Note that VSS is not always ground in a broad sense. What it does is that it provides a stable voltage reference point to the VDD, that's the voltage drain for the circuit. Reference point is like a visual guide to help you judge your measurements. For example, it would be impossible to accurately determine the voltage of a battery without taking the measurement from its reference point, that's the negative terminal of the battery. VSS is an abbreviation for voltage supply zinc, but when there is an A added to it, it becomes voltage supply zinc analog. This simply means you are dealing with an analog circuit. Examples: audio amplifier circuits, power supply circuits, and filter circuits. VEE is used in bipolar junction transistor circuits, and it's also essential in both analog and digital circuits. VEE stands for negative supply voltage and can be used interchangeably with V minus as shown here. VEE is an abbreviation for voltage emitter, and it is used as the reference point to VCC. VREF is an abbreviation for voltage reference. GND, VSS, VEE are all common voltage references. VREF, also known as voltage reference, is a stable voltage source used as a reference point for other voltages in a circuit. Think of VREF like an anchor or a 0 point on a ruler. It is a stable voltage and it allows other voltages to be measured or compared against it. This is the VREF label on this particular board.